everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about sampling distribution. So, when it comes to the sampling distribution, so there are three distinct types of distribution of data. So, very first thing is population distribution and sample distribution and sampling distribution. So what should be this sample distribution here? Sampling distribution. So there are three distinct different types of sampling. So one is population distribution, sample distribution, and sampling distribution. So the population distribution is going to characterize the distribution of elements of population, and sample distribution is going to be characterize the distribution of elements of the sample drawn from the population. And sampling distribution means it is going to be describe the expected behavior of a large number of simple samples drawn from the same population is called sampling distribution. Okay, so the sampling distribution constitutes the theory of theoretical basis of statistical inferences, and which should also be important in business decision making. And sampling distributions are important in statistics because they're going to provide a major simplification on the road to this statistical inference. So there are three types of distributions of data, like population distribution, which is going to characterize the distribution of elements of the population. Means, so here we have a population here. So how we're going to characterize these elements of this population. So that should be the population distribution. And sampling distribution is which is going to characterize the distribution of elements of sample drawn from the population. So we have a population here. From this population, we have to characterize these elements, right? So in that, so how can able to draw from the sample is nothing but a sampling distribution. And sampling distribution means which is going to be describes the expected behavior of a large number of simple random samples. Okay. How can you able to sample 1, sample 2, sample 3, and sample 4 like this? So how can you able to draw the simple random samples from the same population? We call it as a sampling distribution. So mainly this sampling distribution constitute the theoretical basis of statistical inferences. Okay, and considerable importance in business decision making. So the sample distribution going to provide the major simplification to this statistical. Next one, what should be the exact definition for this is? So sampling distribution is the theoretical probability distribution of statistics obtained through large number of samples drawn from the specific population. Okay, so the sampling distribution is the theoretically probability distribution of statistic obtained through a large number of samples drawn from the specific population. So the sampling distribution is nothing but a graph of the statistics, so which means that mean absolute value of the deviation from the mean range and standard deviation of the sample. Unbiased estimation of variance and variation for the sample data. So sample distribution is nothing but a theoretical distribution of infinite number of sample means of equal size drawn from the population is nothing but the sampling distribution. So the sample distribution is a theoretical distribution of infinite number of samples means of equal size taken from the population. Okay, so this means that here the sample distribution is a theoretical probability distribution of a statistic obtained through large number of samples drawn from specific population, and which is going to be mainly used in the purpose of business information, and so where you can able to obtain the sample distribution through mean and then mean absolute value and then range, standard deviation, and the estimation of variance and variance of So like this, we can able to define the sample distribution in many ways. So what are the characteristics of this? So here, usually this should be an univariate distribution. So it should not be bivariate, it should be univariate, and it should be closely approximate to the normal distribution. So how this normal distribution comes? So in this, it should be somewhat similar to this. Okay, since it should be a univariate distribution, and the sample statistics is a random variable, which means that we can estimate through sample mean, sample and proportion, and theoretically probability distribution. The form of sample distribution refers to the shape of a particular curve that describes the distribution. Okay, so the characteristics nothing but, so it should be a univariate distribution and should be somewhat closely approximate to the normal distribution, and it should be a simple statistical random variable which should be obtained through sample mean, sample and proportion, and the form of sample distribution refers to the shape of the particular curve that describes the distribution. So what are the various functions of sample distribution here? Uh, Sampling distribution is a graph which is going to perform several duties to show the data graphically. Okay, so that means where can able the sampling distribution mainly work for mean absolute value, deviation from the mean, range, standard deviation of sample, unbiased estimation of the sample, and variance of the sample. Okay, so the function of sample distribution should be a graph which is going to perform several duties, should show the data graphically, and mainly this sampling distribution works for mean, mean absolute value of and range, and standard deviation of the sample, and the estimation of the sample, and variance of the sample. So like this, the sampling distribution should be uh, a graph which is going to perform several duties to show the data graphically, and mainly the standard sampling distribution works for mean absolute value, range, and standard deviation, variance. So why this sample distribution is important here? So mainly because of these properties of statistics and the selection of distribution type of to model score, and now perform this hypothesis testing. So these sampling distributions are very important. So let's see one by one. So very first thing should be the property of statistics. So the statistics should have different properties, and it should be as the estimator of population parameters. And this sampling distribution able to provide the window into some of the important properties. For example, if the expected value of statistics equal to the expected value corresponding population parameter, so then the statistic is should be unbiased. Okay, so whenever the expected value of the statistics equal to the expected value of the corresponding population parameter, then it should be treated as an unbiased. Here the consistency is under valuable property to have an estimation of population parameter. So as the statistic with the smallest standard error is preferred to as an estimator. So where the estimator statistic is used to estimate a model parameter corresponding population parameter. And then the selection of distribution type to model score, and so here the sample distribution forms provides a theoretical foundation to select a distribution for many useful measures, like for example central limit theorem, which describes wide measure such as intelligence. So that may be considered a summation of number of independent quantities necessarily distributed as normal Gaussian curve. And third one is that hypothesis testing. So normally this sampling distribution is integral to the hypothesis testing procedure, and the sampling distribution is going to be used in hypothesis testing to create a model of what the world look like to give the null hypothesis, which was going to be true, and the statistics was collected as an infinite number of times. And simple sample is going to be taken, and sample is going to be calculated, and then it is going to be compared with the model what is going to be created by the sample distribution. So if the sample statistic is unlikely to give the model, so then the model is going to be rejected, and the model with the real effects is most likely. So what are the different types of sampling distribution? So the types of sampling distribution may be, so sampling distribution of the mean, uh, which is going to be defined as the theoretical probability of distribution of sample means, which is going to be obtained by extracting all the possible samples, and we should also give the first population, final population with the mean and then variance. Mean is going to be denoted as m, and variance is going to be denoted as s square. So the probabilities of sampling distribution may be defined as x bar will be normal, and the mean is going to be presented like this, which is going to be same as mean of the population, and the variance of the distribution will be equal to the variance of population, which is going to be divided with sigma x square, to be sigma square by n. Right? So like this we can distribute the probabilities of sampling, should be normal, and mean of the distribution should be x bar, which should be same as mean of population, and the variance should be sigma x square, which should be equal to the variance of population divided by the sample size. So next we'll see what should be the central limit theorem. So this was introduced by uh, Demore during early of 18th century, which and should be the most important theorem in statistics. So according to this theorem, if you are going to select a large number of simple random samples, so for example from any population distribution, so we have to determine the mean of each sample and distribution of the sample means, which is tend to be described the normal probability distribution, the mean and then variance. So in other words, what we can able to say that, so the sample distribution of sample means approaches to the normal distribution. So let's see how can we prove that. So this is the central limit theorem. So if the population is itself a normally distributed, so the graph looks like this. The sampling distribution sample means to a normal distribution in any size, then it should be like this. So not that much difference is going to be there in between this central limit theorem when compared to the normal distribution curve. So when we are going to give an independent variables like x1 to so on xn, which is going to have same distribution, so then uh, how can able to then can able to write the mean of that x1 plus x2 plus x3 so on x. It should be a normal variant, and the mean and the variance, that should be, so mu is equal to mu1 to mu so on and mu1, and sigma square should be defined as n into sigma with variance. So here n should be added. So where mu and sigma should be the mean and variance of x1. Okay, so according to central limit theorem, so whatever the population itself should be normally distributed. Uh, if we are going to take and independent variables like x1 to xn. So I'm going to write it here like this. It should be normal variant and mean is going to be calculated n into mu1 and variance is going to be calculated as n into sigma square. So the main utility of this theorem is to require no virtual conditions, and which is going to be a sample here. So as a result, it furnishes the practical method of computing the approximate probability value. And this theorem also helps to explain why as a large number of phenomena show approximately a normal distribution. So because of this theoretical and practical significance, so this theorem is not considered as most important. So however, the most of the testing hypothesis and sampling theorem is based on the theorem. So the central limit theorem will show that. And sample distribution of the populations, how can you write it? So the sample distribution of the proportion is formed. So whenever the sample proportion and proportion of success are going to be given. So whenever I'm going to give the sample proportion and proportion of success, so we can able to find the sample proportion of the sample distribution of the proportion. So the properties may be the same proportion tend to be the target value of proportion, and some due to some certain conditions, so the distribution of the sample proportion will be approximately by the normal distribution. So these are the two cases where we can able to identify from some of the properties of this. So let's see an example here. So sample distribution of goals from sample space is going to be drawn. So that means two randomly selected birds here. So here baby means two boys and BG means one boy and one girl. And GB also one girl and one boy. GG means two girls. So this is the sample distribution of the proportion of goals I want to find from the sample space of two randomly selected. So our outcomes of probability likely. So what should be the probability of obtaining 0 goals? So 0.25. And probability of getting one goal is, and probability of getting two goals is 0.7. So this is the probability of finding the goals percentage. So the number of uh, goals from the two birds. So it should, what is the probability? 0.5. So one bird comes in the gun. So what is the probability that? So 0.50. Probability getting two birds is 0.2. So total it should be 1. So 100% should be answers right. So then how can you able to calculate the standard error of the sampling distribution? So the standard error of the sampling distribution is equal to the standard deviation of the population, which is going to be divided the square root of the sample size. So suppose the standard error is defined with the formula like sigma at x mean equal to sigma by square root of n. So x is the standard deviation of the sample mean, x is the standard deviation of population, and n is the total number of population. So how can I able to reduce mean? So whenever the sampling size increases, so the sampling error decreases. So whenever the sample size increases, the sampling error decreases. So this is the standard error of the sampling distribution, where can able to apply the standard deviation of the population. So divided by the square root of this. So this equation is going to be given by sigma into x mean. So that should be sigma by square root of n. So x bar should be standard deviation of the sample mean, sigma is the standard population, and then the sample size. So the main purpose, so can able to find it out. So it should allow us to quantify the extent to which a test provides accurate scores. Suppose if the standard error is the smaller, the range of population mean will be narrower. When the standard error is larger, the range of population will be wider. Right? So whenever the standard error is going to be small, if the standard, then the range of population V will be narrow, decreases. Mean value decreases. So whenever the standard error is going to be launched, so what we have to do? So we have the range of population will be wider. We have to increase the population size. So this is the logic behind this. And see, so what are the different types of standard error tables what are getting? So sampling distribution normally obtained for means, proportions, standard deviations, and medians. Right. So for this mean, so what is the equation? So sigma x mean equals bar is equal to sigma y square root of it. This should be the error rate of the mean. And normally can able to prefer. These are first and third quartiles. And the standard error should be sigma qy is equal to 1.3 to 6.6 per sigma by square root of it. This should be standard error. And for proportion, so what should be the standard error? So this is the equation square root of pq by n. And for semi interquartile ranges, so the sigma q should be this. And standard deviations, which these are the formulas, and variance, this is the formula. And for finding the variance, so what should be standard error? And coefficients of these variations, you can be able to find like this. So these are the some of the standard error rates. So what we can able to obtain here. Okay. So in this video, what I covered is that so sampling distribution. So there are two types of sampling distributions, like population distribution and sampling distribution. So population distribution is going to characterize the distribution of elements of the population, and which is going to characterize the distribution elements of the sample drawn from the population. And sampling distribution should be expected behavior of large numbers and random sample from the same population. So normally, so the exact definition is that so sampling distribution is a theoretical property of the statistics which is going to be obtained through a large number of samples drawn from the specific population. Or it should be a theoretical distribution of infinite number of samples equal size drawn from the population. So the main characteristic should be univariate distribution, and it should be closely approximate to the normal distribution. And normally the statistic should be a random variable, it should be obtained through mean, standard deviation, and proportion like this. And there are different forms of sampling distribution which is going to be referred the particular curve that should describe the distribution. So mainly the function of the sampling distribution will be mean absolute value, range, standard error, unbiased estimation, and variance of the sample. So why the sampling distribution is important means, so the properties of statistics and selection distribution type of model score and mean for the hypothesis testing. So properties of statistics, so already covered. Should if the expected value of statistic is equal, then the expected value corresponding population should be unbiased. And hypothesis testing, so there should be null hypothesis testing and unit hypothesis testing. So it should be obtained so based on the procedure of distribution and types of sampling distribution. So mainly go for the mean here, and in this we are going to find what should be the limit theorem. So the sampling distribution of many sampling means approaches the normal distribution. So the central limit theorem is that. So here we can able to find out the mean value and the variance value for any kind of probability distribution. And some of the sample distribution of proportion. So the example I took here. So what should the probability of finding the girls from the two birds? So out of these two birds, so both are maybe the boys, or both the boy maybe the girls here. So at that time, what will happen? Uh, it should be 75 probability 75. What is the probability of getting one by girl and one boy? It should be 0.50. Probability of getting 0 girl should be automatically 0.2. And this is the standard error of the sampling distribution, and this is the equation sigma x mean is equal to sigma by square root of a. And this is the standard error table. So what I shown is the different formulas that are available for finding the standard error of mean, proportion, standard deviation, and variance. So based on these equations, we can able to easily identify the standard error of the any kind of sampling distribution.
Like, share and subscribe. Hit the bell icon for more updates.